Yes, hi everyone. Welcome back to Power Systems 2 online series. Yes. So now we are in the performance. That is to estimate the performance of the transmission line. Already we completed the short transmission line. That is how short transmission line is there, and how you can estimate the regulation, voltage regulation, and efficiency of the short transmission line. All those things. So we have seen up to yesterday, that is the previous class, and today, and I hope already we solved the two problems. So now let us we solve some more problems in order to have some more confidence to solve the problems under the short transmission line. Let's write in the problem. Let's write in the problem. Yes. What is the maximum? What is the maximum? What is the maximum length in kilometers? Length in kilometers for a single phase transmission line. Single phase transmission line having copper conductor of 0.775 centimeter square cross sectional area, cross section over which 200 kilowatts 200 kilowatts at unity power factor and at 3300 volts, at 3300 volts are to be delivered. The efficiency of transmission line is 90%. Efficiency is 90%. Efficiency is 90%. Efficiency is 90%. Take specific resistance as 1.725 micro ohm centimeters. Yeah, this is the problem they have given. So now we need to find out the value of this. What he asked, what is the maximum length in kilometer? So we need to find out the value of length. So how you find out the value of length? Yes, what is the data he has given? Resistance he has given. and losses you can find from the efficiency, because receiving end power he has given and transmission efficiency is there. So we know that R is equal to rho L by A. From that equation you can, by substituting all the values, rho you know, A you know, and capital R you know, so therefore you can find the value of L. So before that, first you need to find the loss, and from that loss you can find out the value of capital R. Yes, let us we find out that one. The first one is he has given efficiency, that is, yes, what is, how much efficiency is there? 0.9 is equal to 0.9 is equal to output by output plus losses. Yes, what is output here? 200 kilowatts. 200 into 10 cube divided by 200 into 10 cube plus losses. Yes, from this equation find out the value of loss. From this equation find out the value of loss. Yeah, the loss may be like this: 22,222 approximately watts. Yes, what is this loss? This loss is equal to I square R. I square R is equal to this value. I square R is equal to this value. So now you need to find out the value of R. Yes, if you want to find out the value of R, before that you should know the value of capital I. So then how you find capital I? That is power he has given. We will go to the power equation. That is P is equal to VI cos pi. Cos pi is unity. V is, he has given 33,000 volts, and P is 200 kilowatts. So that is 200 into 10 cube is equal to 3,300 into I into 1. From this equation, what is the value of I? Just to solve this equation, find out the value of I, and if you solve that, you will get the value of I as approximately 60.6 amperes. 60.6 amperes. Okay, now we substitute the value of I in I square R is equal to 22222 equation. That is I square R, that is losses. Transmission loss indicates only I square R losses are there. There is no other losses. Yes, I square R is equal to yes, here, and one more thing is there. What is that? In the sense, total loss. Total loss divided by 2, because so we need to calculate the loss for single phase, in the sense 2 wires are there. Is loop in the sense, what is loop? While we are calculating the inductance, there we know that loop inductance is equal to 2 into inductance of the line. So here also the line losses indicates wherever we have the conductor, so that conductor loss also we need to take into account. So hence 2 I square R is equal to total loss. So hence I square R is equal to total loss by 2. 2. So therefore R is equal to 2, 2, 2, 2, 2 by 2 into I square. So now let me know what is the value of R. So if you solve this, you will get the value of resistance as 3.025 ohms approximately. 3.025 ohms approximately. This is the value of R. Next, okay, now we substitute all these values. As we know, R is equal to rho L by A. Yes, what is rho? Rho is 1.725 micro ohm centimeters. That implies what is the value of R? R value is 3.025 is equal to rho is 1.725 into 10 power minus 6 L you need to find, divided by what is A? A is 0.775 centimeter square. So I am keeping all quantities in centimeters as it is. Okay, so therefore whatever the value of L I get, that is in centimeters, then I will convert that centimeters to the kilometers. So hence solve this, L is equal to 1.36 into 10 power 6, or you can also write in terms of kilometers as 13.6 kilometers. Yeah, this is the answer. So what is answer? 13.6 kilometers. Okay. Yes. Let's we go to the another problem. Yes. Estimate the distance over which a load of 15,000 kilowatts 15,000 kilowatts at a power factor at a power factor 0.8 lagging can be delivered by a three-phase transmission line having conductors each of resistance 1 ohm per kilometer, full stop. The voltage at the receiving end is to be 132 kilovolts. And the loss in the transmission is to be 5%. Yeah, this is also problem. So where we need to find the value of the distance only, distance in the sense length only. So how we find? the same process as we proceed, but here it is three phase. So how, in the sense, so first we know that he has given P is equal to 3 V phase I cos pi. I phase, because phase current is equal to line current, so hence directly I used to take I only. Hence what is I? I is equal to P by 3 V phase cos pi. Yes, P already has given. What is P? 15,000 into 10 cube. Yes. What is cos pi? Cos pi is 0.8. What is V phase? V phase is VL by root 3. VL by root 3. Yes, what is VL here? VL is how much voltage he has given? 132. 132,000 by root 3. 132,000 by root 3. Okay, now you substitute all these values and find out the value of I. You substitute that, you will get the value of I as, if anybody has solved, yes, how much value of I you got? It is approximately 82 amperes. It is approximately 82 amperes. Okay, and he states that the line loss is equal to 5% of power delivered. 5% of power delivered in the sense 0.05 into what is power delivered? 15,000 kilowatts. 15,000 kilowatts. Yes, then how it is? How much it is? It is approximately 750 kilowatts. 750 kilowatts. And here we know that loss in the sense three phase loss. So what is three phase loss? Three phase loss is 3 I square R. 3 into I square R. Yes, 3 I square R is equal to 750 into 10 cube. Now here you know the value of I is 82. Then what is R? Yes, R is equal to 37.18 ohms. 37.18 ohms. So what he has given, the resistance of each conductor per kilometer is 1 ohm. The resistance of each conductor per kilometer is 1 ohm. So that means what he states, resistance per kilometer is 1 ohm. That means what is the length of the transmission line? Here you got the resistance as 37.18 ohm. Then what is the length of transmission line? What is the length of transmission? It is very simple problem. That is L is equal to 37.18 kilometers only. Because 1 ohm is equal to 1 kilometer as per the problem. So hence 37.18 ohms is equal to 37.18 kilometers. 37.18 kilometers. Let's write one more problem. A three-phase line delivers A three-phase line delivers 3600 kilowatts 3600 kilowatts at a power factor of 0.8 lagging to a load. 0.8 lagging to a load. If the sending end voltage is 33 kilovolts, 33 kilovolts, determine the receiving end voltage. First one, receiving end voltage. Second one, line current. Third one, transmission efficiency. Transmission efficiency. The resistance and reactance of each conductor are 5.31 ohms and 5.54 ohms respectively. 5.54 ohms respectively. Yes. First, as per the problem given, so first let us find the impedance of the transmission line. And here you can observe that he did not given receiving end voltage. He has given the sending end voltage. From sending end voltage, you need to find the value of receiving end voltage. We have the formula, just we do that. We solve this problem. Z is equal to R plus JXL. How much resistance he has given? This is equal to 5.31 plus J 5.54. 5.31 plus J 5.54. This is the value of Z. Okay. Next, what is sending end voltage? Vs is equal to 33,000, like that he has given. That means you need to find the per phase value, because it is a three-phase line per phase. Hence, it is 3,300 by root 3. Phase value 19 point, tell me, 052 volts. 19.052 volts. Okay. So now let the line current is capital I. Line current is capital I. Receiving end voltage is VR. So then what is equation? I is equal to power divided by 3 into 3 into V phase cos pi r. Is it right? So hence you can write like this, or you can also write power delivered per phase, like that we used to take. Power delivered per phase. Power delivered per phase. So hence directly we will get per phase VR into cos pi r. So here what is power delivered per phase? So he has given that the total line delivers 36,000 kilowatts. 3600 kilowatts, 3600 kilowatt. So that means what we can say? Therefore I is equal to 3600 divided by root 3. 3600 divided by 3 per phase. That means 1200. 1200 into 10 cube divided by VR 0.8. Let it be as it is. Okay, now we have the approximate expression for Vs. What is that equation? Vs is equal to VR plus IR cos pi r plus I into x sin pi r. Yes, here you know value of Vs. Vs is equal to 19.05. That means let me substitute this value. That is Vs is equal to 19,052 volts is equal to VR plus what is I? What is I? I indicates 1200 into 10 cube by 0.8 VR into R, resistance is 5.31 into power factor is 0.8 plus cos pi pi. So then I into XL, that is 1200 into 10 cube divided by 0.8 VR into 5.54 into sin pi. Sin pi is, if cos pi is 0.8, then sin pi is 0.6. Okay, now you can see this equation. It is quadratic equation of VR. Quadratic equation of VR. Okay, now you solve this equation and you will get the value of VR. Solve this equation, you will get the value of VR. That is VR is equal to 18.435 volts. This is phase voltage. Phase volt. Line voltage in the sense VR line voltage is equal to root 3 into VR. If you do this, you will get 31.93 kilovolts. 31.93 kilovolts. Okay. Try to solve this. Yes, now we got the VR. Then what is line current? Yes, the answer, line voltage is 31.93 kilovolts and phase voltage is 18.435 kilovolts. Yes, line current I is equal to, you have the expression, what is that? 1200 into 10 cube by 0.8 into VR. VR is 18,000. Let's let it be 435. You do this, you will get approximately 81.36 amperes. 81.36 amperes. Okay. What about the losses? Third one. To find the efficiency, first let us find the loss. Loss is equal to 3 into I square R. Yes, 3 into I square R. 3 into 81.36 whole square into resistance is 5.31. Yes, it is around 105.447 kilowatts. Okay. Then what is efficiency? Efficiency is 3600 kilowatts divided by 3600 plus 105.447. All are kilowatts only. Therefore, I did not substitute the 10 cube. Hence, what is the answer? How much efficiency? Efficiency is around 97.15. 97.15. Okay. So now we solve one more problem. Yes. Now let us we take one more problem. You take this as work. So still we have the time to solve this problem. A short three-phase transmission line. A short three-phase transmission line with an impedance of 6 plus j8 ohms per phase, 6 plus j8 ohms per phase, has sending and receiving end voltages of 120 kilovolts and 110 kilovolts respectively, 110 kilovolts respectively, for some receiving end load, at a power factor of 0.9 lagging. 0.9 lagging. Determine the first one, power output, and second one, sending in power factor. Power output, sending in power factor. The power factor may be 0.88 lagging. The answer you will get. Okay, the power output may be 1,11,490 kilowatts. Power output may be 1,11,490 kilowatts. Yes, you should solve this. As given receiving end voltage, sending end voltage. So from this you can find the value of I. That is Vs is equal to Vr plus IR cos pi r plus IXL sin pi r. From that equation we can find the value of I. That is around 650.2 amperes. 650.2 amperes. And the power output in the sense is, what is power output? 3 VR I cos pi r. 3 VR I cos pi r. That is VR indicates phase voltage, not line voltage. If you want to substitute the line voltage, you must take root 3 VL IL cos pi. For phase 3 V phase I phase cos pi. Okay, I hope you solve this problem. Yes, thank you for watching this. Hope all are doing good. Stay home, stay safe. Thank you.